all people together. Oh, okay.
There's an echo.
Sure.
We can hear you.
Can you hear online now? Can you hear me speaking, Jakob?
Yes.
Very good. So there is echo. Yeah. Is there still echo when I'm speaking? And can you hear me? Just confirm with a yes in the chat, and if you can hear me. Yes, no echo and hearing. So my laptop is working. The mic on my laptop is working. Should we do that? Run it. Igor, you go ahead.
Yeah, I'm sure.
Yeah. You go. Now you're chairing and the report.
Okay, can you hear me? So should I use this one, this one?
That's a computer. Forget about this one.
Okay. Just turn on this. Okay, so bear with me. I'm on laptop, but I cannot use this laptop. I have to use this one. Okay, so next plan was for this year, and but can you give me this one? Yeah.
Okay.
Can you hear me? Okay. I'm fully connected now. So plan for this year, and plan for next year is to complete. First of all, we had evolutions of our main framework, MDB, Felix. So this is more or less completed now, and it's running in cloud environment. Next, we plan to complete revisiting the validation protocol document and complete all the matchup methods and matrices. You will see also some slides. And then last year we completed 1-day example of TDS for the round robin validation, and now we need to extend it to up to 3 months, and including also remaining data sets. And then for the next year and year after, so we plan to complete full activity for the next week's meeting to report results, and later on and prepare the white paper, and then later on to completely close it down. So what I mentioned before, so the key part now for the activities ongoing in the defining metrics and protocols. The protocols, so basically when we compare also the different MDBs and the functionalities and how all the revisit the previous activities and ongoing our activities on our side, there's a couple of things to address. So in terms of protocols, how do we match? Is it one-to-one and one-to-many matchups, considering the reference satellite and the validation? And we already now saw some the points for the even that are require some further research in terms of the radiometer dataset. For example, for the radiometer dataset, we extract only one measurement per satellite product, while we need to extract full ship track. And this is also the case. We see some for the IST, what we have the radiometers on board the airborne radiometers. So then we need also to change a little bit the way how the extraction is performed. But then we also address if there are some cross correlation between the measurements in the same track. And then for the single satellite pixel versus average satellite pixels, so some teams or agencies are doing only single one, so 1-to-1 pixel, some of them averaging. We think it needs both, because one is maybe identifying more on the cloud masking issue, the other on averaging is identifying more on the retrieval performance. And then we define some time-space criteria, extracted window size, etc. For the analysis, we split between different dependence plots. So latitude, wind speed, total column water vapor, time difference, solar zenith and satellite zenith angle, reference SST, CS concentration, aerosol dynamic indicator, and across track position and time. And then for spatial, we split between space, like global regional maps, and time for Hofmüller diagram. So I'm talking about discrepancies between the satellite measurement and reference measurement, and then identify histograms and Gaussian fit, and also again quantitative metrics. So as you see, quantitative metrics, mean, median, and standard or robust standard deviation is basically at the end, because one number cannot describe how well the data set is validated and so on. So we need much more information and much more metrics to be included. And then we are updating now the online document to include all this information. And then through activity, we identify another one that basically it's ongoing, and it needs to be completed for the round robin activity to extend existing Felix notebooks that we have and some internal code that we have to be able to apply it on the full set of consistently on the full set of MDBs. And what is also important to do is standardization of the file names and the variables. So basically and this is part of the, for all activity like we are following with GDS, to have something with for the matchup analysis. It will be simpler, I would say, because we already defined quite in detail GDS, and then it should just follow up with how we do the variables that are cross related, like a difference between in-situ and reference and the satellite time and the distance, etc. So this is a work in progress. So this is example of the protocols that was identified in terms of the for each matchup database or framework or application. So you see there is so this is not new slide, this is old, but for reference. So for our EUMETSAT Felix MDB, what are the I cannot show you like this. What are the criteria for each in situ or reference type, extraction criteria, and also in situ extraction criteria. So in both for our Felix and CCI MDB, we extract also the history, in situ history time, while for some others it's not extracted, and then we're extracting window sizes, and then for some other are only single measurement. So if we have the same approach, it can easily be, you know, getting from the highest or from the tool set that contains all the underlying setups. We can easily go down to the single level or to the level where we to compare. So here is example. Oops. Okay. Here is example of the current set of matrices and analysis. This is based on SLSTR. And you see that we provide in existing analysis, we provide dependency plots on all the defined variables, so latitude, solar zenith angle, etc. And then also the example of spatial Hoffman-Liouville diagram, uncertainty validation plots, and histograms. So this is kind of the historically how it went. I think it started with the ARC project from Chris and his team, and then implemented through CCI, and basically now more or less the similar set of matrices we are using on our side, and it's proposed also to be used for the task team activity and for the white paper. And what is also important, for example, for the total cone water vapor, so formally it's not part of the GDS, and it's of course needed. It's one of the quite critical parameters to assess whether there's some dependency of the retrieval or not. And then through this activity, we suggest also to expand or include it inside the GDS for the future updates. So this is kind of the indirectly based on the needs. We also improve the GDS specification. This is example of the. I will not go into detail. So this is example of the of the outputs. And as you can imagine, it's what is really standardization. Of course, the important part that the variable names are based from the satellite products are based on the GDS, so we already defined it. File names we can think to improve and needs to be improved. Then in situ or reference satellite reference data sets, we already have some specifications based on the different reference type, like Fred showed before on the radiometer, so it's already well defined. So then it's all this part is well defined, but still we need to consolidate it in one place. And then here is for the next activity. So this is ongoing. What we did. Sorry, there is sound seems to be coming from. There is a message on the chat. Checking this.
Yeah. Can you hear anything now online? Can you hear me speaking, Jakob? Speaking here? So thanks, improving on the technology side.
Can you hear me now from this side? Okay. Okay, so going back, so what we decided, so initially, as mentioned, we compare different MDB tool sets and applications, and we will use the single tool. So it will be too much to compare different tools, but it's not really that we are assessing if the tool is working fine or not, but it's more like really to assess the output. So we assume that all the matchup processes are consistent. And then we use the same, we'll use the cloud platform. This is on our side, Copernicus VKO, so we prepare some resources for this to basically carry on the task. And we identify several, as mentioned, satellite validation data sets from LEO and GEO, and all covering all levels. And for reference data, we identify drifters, mooring, Argo, radiometers. We plan to do also sail drones, but it's always a bit of heterogeneity of the data set where to collect it, and then in having it in single framework, it was for now too much work. If you have something that would be definitely useful. And then for the sources is Copernicus Marine C2, TAC and Ship for SST. How it looks like for the cloud environment. So this is VKO. So basically we have some resources. This slide was presented last year. So here what is extended that we have some capability to have longer time series. So now last year it was really 1 day. Now we extend it to 3 months. And also what we prepared is to basically be able to run Jupyter notebooks through the either VKO system or cloud or directly, because the data are accessible through the object storage, and then full code should be available on the GitHub. So this is last activity what I mentioned to extend to the to prepare the community tool for this analysis. And this is not the output. So this is the outputs what we are having now. So basically more internal activity on EUMETSAT side, where we do the Celestia A, B, AVHR-B extending to AVHR-C, EASI-B, EASI-C extending, VIRS NPP, and we plan to do VIRS NOAA 20. So for cross comparison. So this is how it looks, how it should look like for the outcome of the, let's say, of the TDA, of the round robin. So this is Celestia A, AVHR-B, VIRS NPP. So this is just like example to show you. I didn't put all the plots on the spatial plots and on the spatial plots, but example how it should look like. So for the next activities is we'll plan to have some ad hoc meetings now during GRIST, and we'll set up some more dedicated meeting in July finally. Then, as I mentioned, revisiting validation product document, because it has really useful information inside and should be updated. Then ramping up task team activity, task for round robin activities, and then drafting white paper that's scheduled for the starting next year, and then to have it ready for the year after. For task team members, so I hope we should have definitely some more regular exchange, and then to revisit also the activities and membership, and then using also the Copernicus VKO resources, so for running notebooks, although can be run from local environment. To stress the challenge, so we have the round robin validation task 4 is really critical activity, but it requires a lot of effort, both computational and human, and the matchup. And then we have some ongoing updates and integration of our matchup system. So this was a bit delayed, but also we are lacking a bit of also human effort, so human resources. So if there are some early career scientists interested in all this activity, we would be very welcome to join. So please contact me if you're interested. And I would also add that shared computing environment to allow actually people to collaborate is something that is still, it's very important. Cloud is bringing this, but it's not really immediately available. So it depends also on the funding and everything. And just to complete, this is the last one. As mentioned, we had some delays in the task team and shifting to next year. So basically now for the next year, we plan to complete the round robin results and consolidate conclusions on task team work, plus prepare draft white paper, and then for the 27 to complete it with the reviewed white paper by science team, and hopefully we close the task team with nice results. Thank you.
Thanks for overcoming the technical difficulties.
Okay.
Okay, always first thing. Okay, so I think, yeah, short question, quick question or comment, and to move on in the interest of time. Good. Okay, thanks. There you go. So the next one, Gary Corlett is supposed to present online, and due to the difficulties, the technical difficulties we have, I think we'll postpone that to after the lunch break, so he can give his presentation there at that point, where we have hopefully solved everything. So now we'll just move to Pia English from DMI, who is presenting the task in the high latitude task team.
Thank you. And the sound is still working, hopefully. Oops, just skip through this, right? So, yeah, I will give a short report on the high latitude task team. It's a newly established, or I could say re-established task team that I am chairing together with Steiner Eastwood. And there's been a strong interest